Hi, David Vizard here. I'd like to take a few moments of your time and let you know what's going on in my upcoming seminars. A lot of new stuff here. It'll cover everything from what may be needed by the advanced enthusiast as well as top-notch professionals. Let's go down that road now. Okay, this seminar is designed solely for those people looking for a performance edge, and in many cases a big edge, over the competition, whatever that competition may be. Right, so the subject is solely how to make better output figures from our engine. That includes horsepower and, as I say here, equally important, torque. It'll come up in a minute. Yes, there we go. Torque. Now, you might well ask, what's our target audience? Well, it's everyone who is capable of putting an engine together based on experience of engine assembly, but wants to go on from there. That's at the lower end of the scale. And up at the top end of the scale, this is for people even in the pro stock ranks who want to go faster. I'm pretty damn sure that I can tell almost every pro stock head guy out there how to make 30 horsepower more from their engine. But I haven't seen every one, but I sure can do it for a lot of people. So that's our target audience. Now, as far as the seminar goes, there's 24 hours of seminar time. This is divided up about 2/3 of classroom stuff and about 1/3 in terms of hands-on demonstration stuff. So it should keep things going very nicely, and you should not in any way, shape or form ever get bored. So what will you take home from this seminar? Basically, two things of great importance. Firstly, 2 free programs. One, a very advanced flow program. This will give you data that no other program will give you. And it's relevant data because it will definitely jumpstart your racehead program. The second thing is a program that computes cam specs and then follows it up by not only giving specs of the cylinder heads required, manifolds, carburetors and such, but also will find those parts and give you a manufacturer and a part number for them. It will also tell you the vacuum that the engine's going to have, the torque, horsepower, etc., what octane fuel it's going to require, and so on. There's nothing else that will do that. Right now, you can go from the cam spec right through to the crank rods and pistons without having to look at a catalogue other than this program. So you've seen that smoke test, but we've got something even smarter than that for you. How about a smoke test on a fully transparent LS1 head? I'm sure that will interest a lot of you. You'll see some things with that. If we get around to it, we're going to demonstrate the effect of different droplet sizes in motion in the port. The next thing we're going to do is set up a test with an 18-degree Chevy head, and this one has interchangeable valve seats. The port remains absolutely unchanged, but what happens is we take out these different inserts, seat inserts, and put in different designs. Obviously, when we change seat angles, we change the valve seat angle with it. But for once and for all, this will show a detailed effect of what happens with different seat angles. And I'll also go into details on why what you think happens is not so. Next on the list, now this is going to be exciting. This is a new device which will turn your typical milling machine into a very precise replica of a Surrey, except you can still use it as a milling machine. Yes, accuracy, that's important. This device will get your typical Bridgeport to be able to do valve seat jobs within 1/10 of a thou of position and 1/10 of a thou of axial alignment, which in fact makes it more accurate than a Surrey. The nice thing is, it comes in at a peanut price, right? I ordered one of these the first time I saw it, and I think that it's going to be going to market for probably less than $1,700, right? So this means you can have a machine that will do valves and seats just like a Surrey and mill cylinder heads and do all the other stuff. It's worthwhile covering for just that. Next, this is a simple one. I'm going to show you in about 30 seconds, no, I think that 2 minutes, some lubrication technology that can pick up a useful amount of power, and it takes virtually no time to do. How about 8 greatly overlooked power robbing seat design issues? Here we're going to look at things such as how the form on the seat in the head and the form on the seat on the valve affect the flow. We can change one without changing the other if we start off with one basic premise, which is what we'll cover. Also, CFD has been the coming thing for years, right? My first involvements with it were 25 years ago now, and it was very high tech and it cost a lot of money, but that is changing. So we're going to take a look at some CFD programs that as yet have not come to fruition but are in the making, that will be affordable by the small but seriously power-orientated shop. Let's consider some of the things that we're going to have demonstrations on. These will include how to use the IOP flow bench program. It'll also give details on these 2 new advanced areas of head design. That is induction system energy, which incidentally is becoming very controversial amongst those people who have not got involved with it. Trying to demonstrate how it works, short of having these people in front of me with demo deals, is proving more difficult than I thought. However, we have extremely strong evidence of its function, right? Also, and this is one that I almost guarantee that you will not have heard of unless you're 1 or 2 select people in the cylinder head industry and the F1 business. And that is late phase hyper scavenge. It's very effective, but you've got to know how to apply it. Next on the agenda is to cover porting points relevant to what every professional needs to know. These include the obvious ones. Gasket matching, port matching techniques, faster chamber deshrouding. Now that's an important one. I can cut hours off the time it takes to deshroud a chamber that you don't know where it needs to be cut to. New tech on exhaust. This is not so much new tech. It's been out there for a while in the cup car industry, but they haven't recognized what it is doing what they are seeing. What I've done here is I've attached a new name to it. It doesn't have a name at the moment. And I borrowed this from the aircraft industry from back in the 50s when they were still experimenting with supersonic forms in the wind tunnel and on aircraft. Next on the list is how to get to a fully functional flow bench, really cheap. What we've got here is a lot of our attendees want a flow bench. They don't know how much investment they've got to make in one, or they don't know how to use it at best. we're going to cover that. If you've got $250 up to $25,000, then we can look at what it takes to get the best flow bench for your application. Right, next, port molding technique that's made easy. This one here is a very useful one to know about because it shows you what your work's doing. Now, what we come to now is our number one most popular topic. And it is this, how to get the cam spec right first time. What I mean by that is how to get 99% of the output of an engine from a cam selection right 99% of the time. This relates to an industry average of having it with 95% of capability about 94% of the time. Now, that's much better than it looks there, because 6% off on a 500 horse engine, that's 30 horsepower down. Now, let's have a look at the Torque Master program here and see what exactly it does. With just 8 inputs, and there they are listed, it will compute the best cam for your parts, right, for the parts you put in. But it'll also tell you if the parts aren't up to the job. Right, let's go and look at an input sheet from Torque Master so that I can show you where you put the stuff in and what results it gives. Here we have the opening page. Our first move is to click on this enter button here, and it brings us to this page here. This is the one where we select the brand. Right, we're going to go with a small block Chevy because that's what most of you are familiar with 23-degree heads. So go to enter, and we'll have a hydraulic flat tappet cam. This will be a demo of how much horsepower can be made from a flat tappet cam, very simply without getting into a roller. Right, so hydraulic flat tappet cam, enter. That brings us to this sheet here. What I now have to do is to make appropriate entries in these two spots here, all of these, and these. The relevant ones are this one, bore and stroke, rod length, etc. down to here. Right, at this point we want to decide it on an RPM. Right, and this one here, and whether we want a single or dual pattern cam. So let's configure this for, say, a 383, you know, a high performance one. In which case we'll stick with that 6250 and we'll stick with a dual plane cam. Meanwhile, I need to fill in these numbers starting here. With all the numbers now applied in here, we are ready to have the program calculate the data. So that's where we go to. There, calculate data. Okay, it's come up and told us that that's not going to work. And that's not going to work. Right, what we've got is insufficient vacuum and too much dynamic cranking compressor for a totally street motor. Well, this is actually, we should have configured this for a street strip motor. Now let's have the update again, and here we go. No problems. What we see here is it's calculated the displacement, the piston speed. This here will tell you whether you've got too much piston speed or not. Cam lobe centerline angle, intake duration, exhaust duration, etc. Note the advance is not the usual bread and butter 4 degrees. It's actually computed a realistic one for this setup, 3.4. Right, goes on. Now here's a good thing here, the idle vacuum. It's telling you that. Dynamic compression, cranking pressure, estimated potential foot-pounds 505, estimated potential horsepower 548. We need heads of this CFM flow with this target port there. This is something else that you're not going to get anywhere else. In Torque Master's data bank, there are over 400 flat tappet hydraulic Chevy camshafts. How long is it going to take to look through all those to find a cam like this? Could be a long time. But we can get around that. Let's pull up our Excel program and see what we have. After clicking on Update Excel, we'll get this flashing box down here, which we then open, and it brings us to the screen here, which has the data we've previously entered and has the computations. Now, to find out what part number cam we need really quick, and that's the best of the part numbers, we go down here. First off, we wanted a dual pattern cam, so we deselect that and select just dual pattern. Now all the cams in our list are only dual pattern ones. Now we go to the lobe center line angle. Do the same thing. Select 107. Now we've only got dual pattern 107 degree ones. Let's go here. We want 74.5. Let's see what we've got to choose from. We've got 74 or 75, so that's okay. Well, now one of our cam is now one of these four. So let's move on, right? So at this point they've all got virtually the same features, but let's take a look at some other factors here, right? Let's go there. Right. We've got all the usual stuff here: intake duration 6, 20, 50, 200, minor intensity, major intensity. But look at this, we've got something else here, right? Let's zoom in on that, right? Lobe area. Well, this one clearly has the biggest lobe area, right? But we can look at we can analyze it more than just that. Here we've got the inch, thousandths of an inch per degree on the cam. The bigger the number in this column, the more aggressive the cam. Well, look at this. This is 105.5, right? So this is the cam we'll select, right? 105.5, and presto, there is our cam selected, right? So we go back down here. We can get to ended it. There's our cam selected. Right, now I'm going to go. Okay, start up again. And here in the first column is the part number of that cam. So you can see with just a few seconds work here, what we've identified the cam that's needed for our spec of engine. But let's not forget that it also predicted things like how much flow it's needed at the lift, maximum, minimum recommended lift, but also the volume of the ports. Well, we can go to heads here, right? And we can run the same exercise here. We want a 208 valve, right? That's what we want. 208. Got it there. Now we've only got 208 valves. We want 200 cc port. Let's see what they've got. 210s. Looks like it's the nearest one, or no, 195 or 210. Let's get those. Right. Now, in amongst those heads there are the ones that we can use if we don't have already head selection made. Right. We want 283 CFM flow. Right. So let's nearest one, 284. Let's do that. Right, so hey presto, one of those two heads there. I think the only difference is the springs they may have on them, but there's our head selected. And we can go on. We can go to rocker arms, pistons, crankshafts, rods, etc. So this program not only specs your camshaft, but it guides you to a specification of parts that works best. Also, it will run a total dollar spent column, so that if you're talking to a client on the phone, you can tell them how much they've got to in the way of money spent versus their budget. So it's a very useful program, definitely worth coming to and definitely worth owning. So what more does this seminar show? Well, here's just a few more pointers, and I will have to draw the line somewhere here because this is getting to be a very long presentation about what's in this seminar. But it's a 24-hour seminar. If I'm going to tell you even just the major points, it's going to take some time, so bear with me. Spring tech and valve train setup. There's a lot going on in this department that up-to-date engine builders will need to know, especially in the way of high-performance springs. Bore and ring finishes. The traditional way of doing it is out. If you want to know how it's done in F1 and the very pinnacle of high-performance engines out in the rest of the world, then you need to be at this seminar. Induction tuning. There is such a lot of stuff to be learned here, which we'll go into, and there will be a special question and answers deal just focused on this one aspect. And then there's crankcase windage losses. We've got examples of power losses with crankshafts that have been knife-edged compared with square-faced cranks, coated cranks versus uncoated cranks, and the list goes on. And that makes it for interesting reading right there. And next on the list, zero loss street muffling. A muffler does not have to cost any horsepower. It would be totally possible to make a pro stock car pass legal sound limits with the techniques shown here without losing a single horsepower. Then we've got new V8 exhaust designs. If you've got an exhaust system built by a specialist who's managed to get all those pipes, primary pipes, the same length within half an inch, then rest assured, at best, you have got 2 out of the 8 right. The other 6 are going to be wrong. You'll find out why and how much benefit knowing this information will be to your race exhaust system. Oh, and by the way, Cup car guys still haven't got it right, period. Okay, that covers a lot of what you're going to see in this seminar. One thing I should add is that you will have to sign a non-disclosure form to attend. That's because a lot of the information you're going to get is still proprietary, and that's the way we'd like to keep it. You're getting this information because you're paying for it. We don't want it to get out to the general public as yet until we've moved on from there. So, information on where to sign in will be going across the bottom of the page here, and I advise you to do that fairly soon because we were a sellout on the last 2 seminars. So if you want to be in on the list, you'll need to be signed up a good 2 weeks before the seminar starts. Thank you.